Hello everyone. In this lesson we will be discussing Rolle's theorem and the mean value theorem. Learning objectives. Explain the meaning of Rolle's theorem. Describe the significance of the mean value theorem. State three important consequences of the mean value theorem. Exploration. Consider the function f of x is equal to x minus 2 quantity squared. Sketch a graph of the given function. As you can observe, this function is an upward curving parabola of the original function x squared shifted 2 units to the right. Find the slope of the line connecting -1, f of -1, and 5, f of 5. Using the slope formula, m is equal to f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, where x sub 1 is equal to -1, f of x sub 1 is f of -1, should be equal to 9. X sub 2 is equal to 5, and f of x sub 2, f of 5 is equal to 9. So you plug those into the formula. We have m is equal to, or your slope is equal to 9 minus 9 over 5 minus -1, which is equal to 0 over 6. That will be equal to 0. Part C, find a point of the curve of f of x is equal to x minus 2 quantity squared, where the slope is the same as in part B. So therefore, the slope is 0 of the line that passes that point, touches that point. So a point, if we look on the graph, is going to be the point 2, 0. Part D, what can we conclude based on parts B and C? Our conclusion would be something like, if there exist 2 points on a curve such that the secant line passing through them has a slope 0, then there is at least 1 point on the curve between them, that's between these 2 points, whose tangent line has a slope 0. This is, in a nutshell, what we've come to know as Rolle's theorem. Rolle's theorem, in specific terms, says that f be a continuous function over the closed interval ab and differentiable over the open interval ab. If f of a is equal to f of b, then there is at least one c in the interval, open interval ab, such that f prime of c is equal to 0. So the conditions of Rolle's theorem are: 1. The function must be differentiable on the open interval ab and continuous on the closed interval ab. 2. There exists 2 inputs on the endpoints of the interval that give the same output. The graphs of some functions that obey the Rolle's theorem might look something like these. Here's a downward sloping parabola which has 2 points such that the secant line between them is 0, and because it's downward sloping, it has a maximum, and at its maximum, f prime of c will be equal to 0. Then there's an upward sloping parabola, which again contains 2 points, so that the slope of the secant line between those 2 points is 0. So it will have a minimum at c such that f prime of c will be equal to 0. That's the slope of the tangent line at point c equals 0. And then thirdly, here is a curve which has a secant line between 2 points, a slope of 0. But on this curve, it has a maximum and a minimum, 2 points, therefore a max and min, such that at the max, your f prime of c is equal to 0, and at the min, your f prime of c is equal to 0. To differentiate the max and the min, we call the max c sub 1 and the min at c sub 2. Okay, but the maximum will be their f prime, or your f of c1, and your minimum would be the f of c2. Right, there are some functions such as y is equal to the absolute value of x, which do not meet the differentiability condition. So Rolle's theorem would not hold for functions like these because they do not meet the assumptions of Rolle's theorem, the conditions of differentiability in this case. Practice. Find two x-intercepts of the following functions and then find a c such that f prime of c is equal to 0 in the interval between the two x-intercepts. F of x is equal to x squared minus 3x plus 2. Here we're trying to find the intercepts, the x-intercepts of the function. We know the x-intercepts are when we set the y is equal to 0. They occur when y equals 0 and solving for x. So x squared minus 3x plus 2 equals 0. Implies if we factor that, x minus 1 times x minus 2 equals 0. Solving for that, x will be equal to 1 and x equals 2. Solving for the two factors. So these are our x-intercepts. You will note that at the x-intercept, the slope of the secant line between these 2 points, 1, 0 and 2, 0, is 0. Why? Because if you did your f of x sub 2 minus the f of x sub 1, that's 0 minus 0, that gives you 0. And over x sub 2 minus x sub 1, that's 2 minus 1, that's 1. 0 over 1 equals 0. So your slope is equal to 0. Slope of your secant line is equal to 0. To find the c between the 2 points whose tangent line has the same slope, which is a slope of 0, then we need to find our derivative of our function. So f prime of x is equal to 2x minus 3. At the specific point c, f prime of c would be equal to 2c minus 3. Then setting this equal to 0 and solving for c, set 2c minus 3 equal to 0. So 2c is equal to 3. So our c would be equal to 3/2. So that is a c between the points 1, 0 and 2, 0 that or whose tangent line is 0. Let us look at another problem. Show that the conditions of Rolle's theorem applies in each of the following. Then find a c such that f prime of c is equal to 0 in the interval. F of x is equal to x to the third power minus 4x over the interval -2, 2. For this problem, we will say that because x to the third power minus 4x is a polynomial, it is continuous and differentiable on the interval -2, 2. Specifically, it is continuous on the closed interval and differentiable on the open interval -2, 2. F of -2 is equal to -2 to the third minus 4 times -2, and that gives you 0. F of 2 is equal to 2 cubed minus 4 times 2, and that is equal to 0. So therefore, we find that the slope of your secant line would be 0 because the function values are the same. And therefore, if you do your slope, f of 2 minus f of -2, that would be 0 minus 0, over 2 minus -2, so your slope will be 0 over 4, which will be equal to 0. Find a c such that the tangent line to c, or the x value at c, equals 0. F of x is equal to x cubed minus 4x. So f prime of x from our power laws will be 3x squared minus 4. So then, where you see the x, you replace it with c, so f prime of c will be equal to 3c squared minus 4. Set this derivative equal to 0, 3 squared minus 4 equals 0, and trying to solve for c, algebraically, 3c squared is equal to 4 if you add 4 to both sides. C squared will be equal to 4 over 3. So then c will be equal to plus or minus square root 4/3. So now there are two possible solutions.